Okay, finally getting out of the sections 1 and 2 and now into section 3. Solving for multiple angles. We're going to do a lot of the same things that we did before, but instead of it being equal to theta, it might be equal to 2 theta, 3 theta, 1/2 theta, whatever. We got to do a little bit of extra solving. Okay, so for example, here I've got the tangent of 3 theta is equal to -1. I am going to take the inverse tangent of both sides of this, just like I would have done in the past, to get 3 theta all by itself, and the inverse tangent of -1 would get me a reference angle of 45 degrees. Now, because it's tangent and it's negative, that is going to put me into the certain quadrant. That quadrant is going to be in the 135 area, right? All students take calc. So one of my possible angles is going to be, here, maybe I'll draw it real quick. Reference angle 45, so here's my 135 degrees. So really what I'm dealing with is that 3 theta is equal to 135 degrees. Now, because it is tangent, I'm going to add this 180k, where again, k is the number of periods that it's going to take. Here's the extra spot that's new from before. I'm now going to divide everything by 3. And that leaves me with theta is equal to 45 degrees plus 60. Okay. Now, how is that going to kind of affect me? Well, I can take and I'm going to add 60 to get to my next angle of possibilities and go from there. So I could just go 45 plus an additional 60 plus an additional 60 until I hit my full period. Okay, now that would be in quadrant number 2 because that's where tangent is negative. I've also had this case where it is also negative in the fourth quadrant. So I've got a reference angle of 45 right here. So this angle is another possibility for 3 theta to be equal to, and that would be 315 plus 180k. And then when I divide out that 315 by 3 and the 180 by 3, I'll get theta is equal to 105 degrees plus 60k. So, yeah, that's kind of what we're doing, just adding another 3 theta. Now, this would be really the all solutions when I'm adding the plus 60 and when I'm adding the plus 60. 45 and 105 would be my 2 solutions. And that's because of tangent being negative in that quadrant. Okay, so I'll do the same thing. Now, maybe I'll simplify it a little bit. I'll take the 3 theta out. So I'll kind of come up with this idea that whatever I get when I solve for this original angle, so maybe here like this, I'll go 2 sine squared of x minus sine of 3x minus 1 equals 0, where x is equal to 3 theta. So I'm going to solve for x just like I would in algebra. In fact, I'll even take the signs out and make it 2x squared minus x minus 1. And whenever I get there, I'll add the sign back in. So maybe I'll say that x is equal to the sine of 3 theta, just to help you with the algebra. So I'm going to factor this like I would before. Factors of 2x squared, x and 2x. Factors of -1, so plus 1 and -1. I'm going to set each factor equal to 0 and solve. And I get 2x equals -1. X is equal to -1/2. And I get x is equal to +1. Okay, but remember, x was actually the sine of 3 theta is equal to -1/2, and the sine of 3 theta is equal to +1. Okay. Oops. So I'm going to get rid of the signs. So I'm going to get the inverse sine of -1/2, and 1/2 really has a reference angle of 30 degrees. So I've got 3 theta is equal to, okay, again, sine is negative, so it's going to be in quarter 3. That 30 degrees is actually going to be 210 degrees If you're not quite sure how I got that, draw out there, put the 30 right here and find that whole angle. Okay, I'll take the inverse sine to get of 1, so get 3 sine is equal to 90, or 3 theta is equal to 90. And again, I got that from the unit circle, but I took the inverse sine of both sides. Divide by 3 here, and I get 70. Okay, divide by 3 here, and I am going to get 90. Okay, now, because it is all the solutions, okay, I can do this. I'll go 3 theta, instead of it just being 210, I'm going to add 210 plus 360 degrees K. If I divide all those by 3, I end up getting a theta is equal to 70 degrees plus 120 degrees K. Okay, I'll do the same thing over here. I've got 3 theta is equal to what's going to be 330. Okay, now where did I get the 330? Oh, I guess I forgot. This negative sign also exists in another quadrant, right? It actually exists also in quadrant number 4. So I should be finding that 3 theta is equal to 330 as well. Okay, or theta is going to be, right, divided by 3. 110, right? Because I got all students take calc. I should have 2 negative signs that are both in those 2 quadrants. Okay, so then I'll take 3 theta is equal to 330 plus 360. Okay, divide them all by 3, and we get theta is equal to 110 plus 120. Okay. And then I guess I could do the same thing for that 90, right? I got 3 theta is plus is equal to 90 plus 360. Okay, or if I divide by 3, theta is going to be equal to 30 plus 120. Okay, so if I'm talking about from the very beginning, my 3 angles of being 70, 110, and 30. Okay, so that's from just the general, keeping it within the one circle. If I expand this, but really, wait a second, my general full circle is between from 0 and 360. So if I go 70 plus 20, 120, and go 70 plus 120, isn't 190 also within that circle? And if I add another 120, doesn't that put me at 310? So that is also within that circle. So there are 3 angle measurements that will make that true right there, still within that first revolution around the circle. Same thing, if I go 110 and I add an additional 120, that puts me at 230, that's within the circle. And I add a 120 to that, that is 350. I go 120 more, and that's going to put me past 360, so there's 3 more. Okay, and then I go 30 plus 120, that's going to put me at 150. If I take 150 plus another 150, that puts me at 270, which is also 3 more. So actually, I got quite a few of these angles that are going to fit between theta being between that 0 degrees and that 360 degrees mark. Okay, all because dividing that by 3 took that extra circle business down from 360 to 120. Okay, that's a lot to chew on, but hopefully that makes a little bit more sense. Let's try one more, but we're going to do it in radians, I believe. Oh, no, I take that back. That's for another video, and I'll do that again, hopefully slow that down for you.